Hello everyone, welcome to the last section of our 3.1 notes. This is 3.1 notes, tangent ratio, and we're going to look at part 3. So I've just divided this set of notes into 3 parts, and this is the last of the 3. We're going to discuss how to solve problems, finding either an unknown distance, so an unknown side length, or an unknown angle. And this is going to involve 2 things. One is going to be using the tangent ratio. So we're going to have to use tan of theta is equal to opposite over adjacent. This is really important to us. Okay. The other thing that we are going to need is that the angle theta is equal to the inverse tan of the opposite over adjacent. And finally, we may need to rearrange this equation here. If we're looking for an unknown side length, we might be looking for the opposite side or the adjacent side, in which case we may need to rearrange our formula. So we're going to have to do a little bit of practice with rearranging formulas as well. So let's start with our first example. It says find the length of the side CB. Well, whenever you have a trigonometry question involving a right triangle, the first thing you should do is label your triangle. Okay, so label all the sides of your triangle that you know. Okay, well, the first thing I see here is that I'm given one side length, 23.0 centimeters. The other thing I'm given is an angle. I'm given the angle A. Well, that's the only angle I'm given, so that's going to be the angle that I'm going to work with. Okay, so I'm going to choose when I go ahead and do this question. I'm going to let angle A be my angle of interest because it's the only angle I have. So let's label this triangle relative to angle A. So the first thing I'll do is I'll label the side across from angle A as my opposite side. And then I'm going to label the side right across from the right angle. There's my hypotenuse. Okay, and finally then the leftover side is going to be from C to A, and that's going to be my adjacent. And I see that I'm given the length of the adjacent is 23 centimeters. So I'm looking for the length of side CB. Well, let's have a look. C to B is right here. Okay, so the unknown length, so the length of CB is what I'm looking for. Okay, that's going to be my question. And I notice that CB is the opposite side in my triangle. Okay, so what I'm looking for is the opposite side of this triangle. What I have is the angle, I have the adjacent, and I'm looking for the opposite. Let's use our tangent ratio for this. So the tan of an angle, and this time I know we're looking at the tan of A. So the tan of A is going to be equal to the opposite over the adjacent, and I know what A is. I know that the tan of angle A is 28 degrees. Okay, and that is equal to the opposite, which I don't know. This is the one I want. This is what I'm solving for. Over the adjacent, and the adjacent is 23.0 centimeters. So I have that value. So what I need to do here is I need to rearrange this equation. Before you do that, you could compute in your calculator what is the tan of 28. So in your calculator, let's do this. This is simply, we press the tan button in our calculator, and then we type in 28 for the angle, and let's see, what do we get? I get 0.5317. Okay, so 0.5317 is equal to the opposite over 23. Okay. You're just trying to solve for the opposite. You would like to get the opposite by itself on one side of the equal sign. I see that right now the opposite, okay, the unknown side is being divided by 23. I want to undo what's being done to it. So I'm going to times this ratio by 23.0, okay, in order to cancel out the 23 on the bottom. Okay, I want to isolate the opposite side. So I'm going to multiply it by 23 so that I cancel out the denominator. And I have to do the same thing over here. This is how you rearrange an equation. Okay, you undo what is being done to the thing that you want to isolate. The thing I want to isolate is the opposite, so I undo what's being done. It's being divided by 23, so I multiply by 23. And I have to do the same thing to the other side so that they're both equal. And what I end up with is that the opposite, I'm just going to write this over here. Okay, so the opposite then is equal to, I have 23 times 0.517. 5317. I can put that into my calculator, and my answer works out to be 23 times 0.5317, 12.2. So my opposite side is equal to 12.2 centimeters. I know I'm in centimeters because my adjacent side was in centimeters, and that is my answer. So if you're given a triangle, you're given an angle, and you're given one of the sides, you can use the ratio to determine what the unknown side length is. Let's do another example in your notes. Okay, this time we're going to calculate the side of PQ. Again, step 1. Label your triangle. Label the sides. Okay. Again, I see that with this triangle, I'm given one of the angles. I'm given angle P. It's equal to 35 degrees. Okay, so angle P is equal to 35 degrees. So I'm going to label my triangle relative to angle P. So label your opposite and your adjacent using P as your angle of interest. Okay, so across from angle P is this side right here. There's my opposite side, so it's equal to 5. My hypotenuse is always easy to label. It's always the side across from the right triangle, so there's my hypotenuse, which leaves the other side of this triangle right here from P to Q. That's my adjacent. Okay, I'm looking for the side length of PQ, so I am looking for PQ, which is the adjacent side. Okay, that's the side I'm looking for, PQ. Okay, excellent. So let's go ahead and write what we know. I know that the tan of an angle, and in this case it'll be angle P, the tan of P is equal to the opposite over the adjacent. And I have P. I know P is equal to 35 degrees, so I'm going to put that information in. Okay, I know that P is equal to 35 degrees. Great. And that is equal to the opposite, which I also know it's 5.0 centimeters. So I go back to my triangle and I see what I know. If I have a value, I'm going to put it into the formula. And anything that I don't have, I'm just going to leave. So the thing that I don't have is adjacent, so I'll just leave it as adjacent. Okay, but this is what I'm solving for. Okay, I want to isolate this. So what I want to see is, once I've rearranged my formula, I want adjacent is equal to something. I want the adjacent side, okay, ADJ, I want adjacent all on its own on one side of the equal sign, and I want everything else on the other side of the equal sign. So again, when you have a question like this where the thing you want is in the denominator, you can move it out of the denominator by multiplying both sides by the adjacent. Okay, there's two ways you can do this, and I'm just going to show you both ways so that you have more than one tool in your toolkit. When I have something in the denominator, to move everything out of the denominator, or essentially cancel the denominator, I can multiply both sides by whatever I see in the denominator. So if you multiply that side by the adjacent, and I multiply this side by the adjacent, okay, the adjacent will cancel here, so these two cancel to give me 1. And now I have the adjacent side times the tan of 35 is equal to 5. Okay, so again, I want adjacent. This is what I'm trying to get over here. I want the adjacent to be all by itself. It's now being multiplied by the tan of 35. So I'm going to undo what's being done to it. Okay, I'm going to write it out down below so that it's a little bit more tidy here. So it's being multiplied by 35, tan of 35, and that's equal to 5.0 centimeters. So what I'm going to do is I'm going to divide both sides by the tan of 35. Okay, I'm going to divide. I'm dividing by tan of 35 because the adjacent side is being multiplied by tan of 35. I want to undo what's being done to it. So the opposite of multiplying is dividing, so I divide by the same thing. Okay, that cancels out the tan of 35. I have 1 now over here, adjacent times 1. Okay, I'm going to have to also divide this side by the tan of 35 because whatever I do to one side, I have to do to the other side. So now I have adjacent equals 5.0 divided by the tan of 35. Let's use our calculator to determine what is the tan of 35. So in my calculator, I'm going to hit the tan button, and then I'm going to enter in 35. Okay, and that is equal to 0.7002. So now I can compute this. 5 divided by 0.7002, the adjacent side is equal to 7.1 centimeters. 5 divided by 0.7002 is 7.1. Okay, I've solved for the unknown side. I want to show you one other way to rearrange this formula right here. Okay, coming back here to this question. You can just write this either to the side of your notes or maybe on the back of your notes, or on a set if you've got a separate piece of paper handy. The other way that you could rearrange the formula is by using cross multiplication. Okay, it looks like this. If you have, our original formula was this, the tan of 35 is equal to 5.0 centimeters over the adjacent. And the adjacent was what we were interested in. We wanted to solve for the adjacent. Over here on the right-hand side, I multiplied both sides of the equation by the denominator, by the adjacent. The other sort of shortcut that you can do here is you could cross multiply. So when I have tan of 35, this is the same as the tan of 35 over 1. Okay. To bring all of everything out of the denominator, so in order to get rid of the denominators, you can cross multiply. So you're going to simply multiply across like this. Okay, so you're going to multiply the tan of 35 times the adjacent. The tan of 35 times the adjacent is equal to, and you're going to do the same thing on the bottom. You're just going to multiply 1 by 5. Okay. This is cross multiplication. When you have a formula that has something in the denominator, you can, and an equal sign, okay, an equation, you can cross multiply the numerators and the denominators together, okay, and that will bring everything out of the denominator. So now you have the tan of 35, okay, times, I'm just going to use brackets here now to show multiplication, times the adjacent is equal to 1 times 5, which is just 5. And then again, I would have to divide both sides now by the tan of 35 in order to get rid of the tan of 35 on the left hand side. Okay, I want to get rid of the tan of 35 over here because I want adjacent to be all by itself. So I have adjacent is equal to 5.0 over the tan of 35, and now I'm in the exact same place that I was over here. Okay, I just simply have to do the math. So there's two ways to rearrange a formula. One is to simply undo what's being done to it, okay, or multiply both sides by what you see in the denominator to get rid of the denominator. The other way is to simply cross multiply the numerators and the denominators, and that will also bring the denominators up into the numerator. Okay, if you need a little bit of extra help with rearranging formulas, please just let me know. I'd be happy to do some more examples with you. Just send me an email or come and see me. Okay, one last example for us. I like to do this example because it's a problem. We don't have a triangle, we don't even have a diagram, we just have a problem. Here's a problem. A wire supports a flagpole. Okay, so I'm going to draw my flagpole. You always want to draw yourself a little diagram for these types of questions. There's my flagpole, and a wire is supporting it. Okay, we'll have to read the rest to figure out where the wire is. It says the angle between the wire and the level ground is 73 degrees. Well, here's the ground. And it's level, okay, so it's flat, level ground. And it says that there is an angle between the wire and the ground. So our wire must be attached from the ground to the flagpole. Okay, it says that the wire is anchored from the ground, so there's our anchor, is anchored from the ground 10 meters from the base of the pole. So there's the base of the pole, so from here to here is 10 meters. Okay, and so we're going to assume then if this is where our wire is anchored and it's supporting the flagpole, it must go up here. Oops, sorry. It must go up to the top of our flagpole. Okay, forming a right triangle. Here's my wire, and here's my pole. The first step when you have a question like this, a problem, draw yourself a diagram based on the information in your problem. It asks us how high up the pole does the wire reach? Okay, so we don't know right now. The wire could reach the top of the pole the way I've drawn it. Maybe the pole is higher than this. Maybe it's only, maybe the flagpole is quite high and the wire is only reaching part way up the pole. We don't know yet. We're going to find this out. What we do know is that the angle between the wire and the ground is 73 degrees. So between the ground and the wire, here's the angle that is formed between the wire and the ground. This is 73 degrees. So we've drawn ourselves a diagram, and we want to solve for the height of the pole to the top where the wire reaches it. Okay, so it's right here that we're solving for. I would like to know, this is the height, okay, so this is my height. Height is equal to what? Okay, what is the height of the pole where the wire reaches it? I have a right triangle. I see that this is my right angle right here. And so if 73 degrees is my angle of interest, I could label this triangle relative to 73 degrees. So I could label the side across from 73 degrees is my pole. Okay, so here's my opposite side right over here. Okay, and my hypotenuse is going to be the side that's directly across from the right angle, which will be it's going to be my wire in the diagram. So there's my hypotenuse. And finally then that leaves my ground, my 10 meters, as my adjacent side. This is looking a little bit messy, so I could right now just sketch myself a little bit more of a clean right triangle over here. Okay, and I could write hypotenuse 73 degrees. Okay, I know that this is my adjacent is equal to 10, and my opposite is the one that I'm looking for. Okay, that's what I'm trying to solve for. So we've drawn ourselves a diagram, we've labeled our diagram. Now we're going to solve for the opposite side. Okay, let's use our tangent ratio. The tan of the angle, which is 73 degrees, is equal to the opposite, which I don't know, over the adjacent, which I do know, and it's 10. All right, I'm looking for the opposite side, so I want to isolate. I'm going to have to rearrange because I want to isolate the opposite side. I want to isolate OPP in this formula. So what I want to see in the end is that OPP is equal to something. So I want OPP all by itself on one side of the equal sign. And I see that I have, right now in my formula, OPP is being divided by 10. So I'm going to undo what's being done to it. I'm going to multiply by 10 over here. And I'm going to have to do the exact same thing over here. I'm going to multiply this side by 10 so that 10 cancels in the denominator. Now I have 10 times the tan of 73 is equal to the opposite. And in your calculator, you can compute the tan of 73. This is equal to 10 times the tan of 73 is equal to 3.2709 if you put tan 73 into your calculator. Okay, and so we get as our answer, the opposite is equal to 332.7 as our answer. Okay, let's go back to our diagram for a minute. That means that the opposite side, okay, right here was 32.7 meters. I know I'm dealing with meters because my adjacent side was in meters. So the wire reaches 32.7 meters up the pole. And there's my answer. If I knew how tall the pole was, I would know whether or not that wire was reaching to the top of the pole or not. Excellent. So those types of questions are the most difficult simply because you have to come up with a diagram yourself, and then you have to relate the diagram to a right triangle, okay, and solve for the unknown part. Got one more question here in your notes, and this one is asking us to find an angle. So let's do this one. This is another good example of using the tangent ratio to find an angle. So it says Victor is building a wheelchair ramp to an entranceway that is 3 meters above the sidewalk, and the ramp will cover a horizontal distance of 50 meters. What angle to the nearest degree will the ramp make with the ground? You already have a diagram, which is really helpful. What you should do now then is make some sense out of this diagram. Okay, so I can see that if I go back, I can see that we're building a wheelchair ramp to an entranceway that is 3 meters above the ground. Okay, so there's my entranceway right over here. So that means that the 50 meters, that must be my horizontal distance along the ground. So here's my ground. And that means that from R to Q, that must be the distance of my ramp. Okay. What angle will the ramp make with the ground? Well, that's going to be the angle made right here. There's my ground. There's my ramp. Okay, so it's the angle Q. So we want to solve for the angle Q. That is what we're trying to find in this question. Okay, so we start off, we've made some sense out of our diagram. Let's label the diagram. And when we label the diagram, we're going to label it relative to the angle Q. So let's label our triangle. I start with, this is the angle that I'm interested in right here, angle Q. So the side opposite from Q is over here, it's the 3 meters. Okay, the hypotenuse is going to be the ramp, because it's directly across from the right angle, which means that the leftover side is the ground. So this is, the ground is my adjacent side. Okay, I'm going to use my tangent ratio here to figure out what I have. The tan of Q is equal to the opposite over the adjacent, and I know that the opposite side is equal to 3 meters, and the adjacent side is equal to 50 meters. So the meters are going to cancel here. I have 3 over 50. So the tan of Q is equal to 3 divided by 50. In my calculator, I take 3 and divide it by 50. That's 0.06. So the tan of Q is equal to 0.06. I am looking for an angle. I'm not looking for the tan of Q. What I want is the angle Q. Okay, so Q, the angle Q, is going to be equal to the inverse tan of the ratio, or the inverse tan of 0.06. So the angle is going to be equal to the inverse tan of 0.06. So in my calculator, I'm going to either, if I have the button tan to the -1, I'll use that button. Otherwise, I'm going to press shift or second function tan to take the inverse tan, and I'm going to type in 0.06 because that's my tan ratio, and Q is equal to the inverse tan of 0.06 is 3.43 degrees. The question asks us what angle to the nearest degree will the ramp make with the ground. So the nearest degree is, here's my nearest degree, so the nearest whole degree. So I'm going to round this up to Q is equal to 3, because I see that 4 is the next number after the decimal, and 4 is not a number that's large enough to round up the 3, so we'll leave it as 3 degrees. So Q is equal to 3 degrees, and that's my answer. So the ramp makes a 3-degree angle with the ground. Excellent. Folks, at this point you can finish up your 3.1 worksheet, so you can try questions in part 2 of the worksheet and check your answers. The answer key is posted on the website for you to have a look. Thanks so much for joining me, and we will see you again soon. Bye for now.